So last week we looked at the biblical precedents, the kind of building this idea of knowledge of God, that the knowledge of God is possible, and what these points of access to gain, to acquire this knowledge of God. And starting from the Genesis story, from the creation of the first human, Adam, who is made in the image of God, and male and female, to Exodus and Moses, and God, knowing God's attributes and whatever it means for God's face and back and hand and that communication, to Isaiah and the entering into God's court, or to God's palace, the Heichal, and that we'll see that also come back, and to Ezekiel and the chariot and the luminance and colors and radiance separate from the beings that were below it, and to Daniel and the whiteness of his beard and hair and robes, and also the court in which they're in, and on all this kind of building up to these questions of what do these images even mean and how to take them, but they're understood already in the time of the Talmud, and more clearly by the time of Maimonides, the 12th century, that again, that knowledge of God is possible, but knowledge of God is also knowledge of the universe. The two are the same. And then something we didn't really touch on, but gets folded into it too, is that that knowledge, because the Torah because the world, for already in the rabbinic understanding, but certainly in the Kabbalistic understanding, that the world itself is created through the Torah, that the Torah precedes the world, that under the knowledge of the Torah and knowledge of God and knowledge of the universe are all the same. And so that the access to these are overlap. And so that the goal of Kabbalah, the primary goal of Kabbalah is to gain this knowledge of Torah, God, and the universe, and union with Torah, God, and the universe through this study. And we're going to look at two texts from the Torah, the very opening of the Zohar. Sefer HaZohar, which is the book of radiance, takes its title from a passage at the end, the way end of the book of Daniel. And it was a book that from already its introduction was filled with mystery. It was distributed by Moses de Leon at the end of the 13th century in Spain, and pamphlets, and he was distributing it, saying that he found an ancient manuscript of Rabbi Shimon Bar Yochai, a Mishnaic rabbi who's famous for hiding in a cave with his son and studying and living in a cave eating carobs. This is according to the rabbinic tradition. So Moses de Leon is distributing this pamphlets, saying that he found this ancient text, and it's written primarily in Aramaic, or basically entirely in Aramaic, which is no longer spoken by anybody. And so it's written in Aramaic, and because they are both not Aramaic speakers, and the lexicon that they need is broader than the Aramaic language existed when people stopped speaking it, they're making up words from other languages to try to fill it in. So you'll see even in this text, which has the Aramaic above, for those who might be able to follow through with it, there are many words in it that don't exist anywhere before in Aramaic nor anywhere else. And these passages are from their beginning of the commentaries. So the Zohar is structured as a commentary on the 5 books of Torah, and these commentary on the opening verses of the Torah in creation. So there we go. Okay. So this first passage is actually, I have here just as a reminder, the opening of Genesis. And I think maybe just a few things to know so it's Bereshit bara Elohim et hashamayim ve'et haaretz. So when God began to create heaven and earth, it's already always important in the rabbinic period what name of God is used. In this case, it's Elohim, and we'll see that come back quickly. And Vayomer Elohim vayhi or, God said, let there be light, and there was light. they're going to also they're going to interrogate very quickly whether this was a creation or whether this light pre-existed or didn't, or was created then by God. And another thing quickly to note in this passage is on the final verse, verse 6, because God said, "Let there be an expanse in the midst of the water, that it may separate water from water." But the water, as we have in verse 2, already was there. So the earth being unformed and void, with darkness over the surface of the deep, and wind from God sweeping over the water. So water had not been created, but is mentioned. And we have this light and this expanse that divides the two, right? So they're already looking at these elements, trying to understand what is going on in this early moment. But thinking back to that Mishnah text that we started with last week, that we shouldn't ask what comes above and below, before and after. They're going to go as far back as they possibly can in this opening verse, in this opening commentary. So in the top is the Aramaic. This is the translation of Daniel Matt in a multi-volume edition that he released on translating the entire Zohar. So in the beginning, Bereshit, Genesis 1:1. At the head of the potency of the king. All right, so we've already had, again, images that we've seen from the Bible of a king in his court, and here they're picking up on that right away. He engraved engravings in a luster on high. A spark of impenetrable darkness flashed within the concealed of the concealed. So note that it's a spark and it's dark, right? So remember last week when we talked about the things that were opposites being contained in the same, male and female, or in the image of Isaiah, that both it was in the court but also filled the entire world. These questions of containing opposites you're going to see so throughout this passage. So a spark of impenetrable darkness flashed. So what does it mean to flash in darkness? Within the concealed of the concealed. And it's not seen because it's concealed. So what is, this is already how we trying to understand this image, or this knowledge of this image. From the head of infinity. In the Aramaic for this, or Hebrew, is Ein Sof, without end. A cluster of vapor forming in formlessness. Right? So here in vapor, you just only think of having a cluster, right, of any kind of shape at all. But it's a cluster of vapor forming in formlessness. You can try to make sense of that one. Thrust in a ring, not white, not black, not red, not green, no color at all. Right. So think about this in comparison to the Daniel text, which describes the whiteness of the robe, or even in the text of Ezekiel, where you have the description where he's trying to say it's like amber or it's like sapphire. Right. So there, where all these colors are being attributed, look what's happening in this early stage. They're making clear. Right? It's whatever this is, it somehow has no color at all. As a cord surveyed, it yielded radiant colors. Deep within the spark gushed a flow, splaying colors below, concealed within the concealed of the mystery of the infinite. It split and did not split its aura, was not known at all until under the impact of splitting, a single concealed point shone. Right? So here it's splitting, but it's not splitting. It's concealed in this mystery, yet somehow it's being seen or understood. But really nothing's known until a single point shines through here. Right? So kind of through this total hidden, impenetrable, concealed darkness and the infinity, a single point comes out. And everything seems to be kind of extending from that line. And here that as a cord surveyed, is it really an image that appears in several times in the Zohar, more precisely in a passage called The Secret of the Letters, a really particularly difficult section. And imagine, I guess, if you have a single point, you have no direction. It has no, is that one dimensional? I think it is, where you don't know if it's going right or left, up or down, right? You have no indication of any difference. But once that line starts moving just a little bit, you have a sense of direction, and it starts limiting, right? It's traveling somewhere, it's defining somewhere, it's maybe gaining some shape. But part of the image here is that nothing yet has any definition. It's no different. It's a single point that somehow contains all of this and none of this. Right? It's formless vapor, it's form, it's color, it's not color, right? all these things are contained in the single point that hasn't yet been defined. Beyond that point, nothing is known, so it is called beginning, Reshit, first command of all. Right? So here in this opening of the Zohar, they're coming back to this first word and they're understanding it in some sense, not as in the beginning, but like with this beginning, and this beginning being this initial point. And everything, though they write here, beyond that point, nothing is known, they seem to have just described, at least to what happened, what they do know, which is that it's maybe not colors, but they seem to be splaying out some of the drama of what happens beyond it before this initial point, right? So they're pushing at the bounds of the limits of knowledge, and we're going to jump to just a few pages later, and it begins with a particularly a beautiful principle of how they're going to try to engage in learning more about the creation. And it's for anyone who studied legal text, it's something that will sound familiar. It's klal upratu klal, which is a legal principle where if you have a long description of laws, if it begins with the general and then has a particular instance and then finishes with the general idea, you can derive other particular principles from, because it has the particular in the middle. So anything that's like it can be applied. And they cobble it, the authors of the Zohar here look at the creation story and see, in the beginning, God created heaven and earth, Bereshit bara Elohim et hashamayim et haaretz, and at the conclusion of the creation story, it repeats again, and this was the creation of heaven and earth. So these are the general, and now they have the particular in the middle. So because there were some particulars in the middle, they feel permitted by this principle of klal upratu klal, the general, the particular, and the general, to be able to figure out more particulars in the middle. Right? I think it's such a kind of beautiful and strange moment to take a legal principle, and here they're trying to use it to apply to understand the earliest notions of the universe, which to me feels like a physics principle. Right? If physics is true and you can understand the laws of gravity, they're equally true right now on Earth, and they were immediately after the inflation. Right? And there's some kind of corollary here in finding principles and applying them once you've, again, within their understanding, once you've proven them true. And so this is now on the third verse. God said, "Let there be light," and there was light. Here begins the discovery of hidden treasures, how the world was created in detail. For until here was general, and afterward general returns, constituting general, particular, general, klal upratu klal. Until here, all was suspended in space, avirah. So there's a word, you can see it up if you look at the Hebrew, or is aleph vav resh, and avir is aleph vav yud resh. So the only difference between those two words is the yud and avir. And you'll see where that plays into it. Until here, all was suspended in space from the mystery of the infinite, the Ein Sof. Once the force spread through the supernal palace, so here's these, like the palaces that we had referenced in Isaiah and in Daniel, the mystery of God, saying is ascribed. God said, Vayomer Elohim. Above, saying is not specified, although in the beginning, Breshit is a saying, said is not ascribed. So here, what they're defining is creation without any language to creation with language. And we're going to see that getting defined in three stages between silence, speaking, and writing, right? And as these, among the images of the developments of creation of the world. This set is susceptible to questioning and knowing, right? So unlike the Reishi, which is kind of this at the limits of knowing in its silence, this, once it's being said, it becomes an understandable principle. Said, Vayomer, a power raised, rising, and there's a wordplay here between Armuta, rising, and Vayomer, silently formed the mystery of the infinite in the origin of thought. God said, now that palace, impregnated by the seed of holiness, gave birth, giving birth silently, while outside the newborn was heard. The one giving birth gave birth silently, was not heard at all. As the emergent one emerged, a voice was generated, heard outside. We're not going to try to understand all these images, but they're working here off notions of creation and birth. But the thing I really want to kind of focus instead on more the difference between the silence and what's heard. Right? So there's a point when you can't hear anything, when it's in total silence, that remains outside of our knowledge. But once something is heard or spoken, here the Vayomer and God said, it begins this place of deep understanding rather than limited understanding. This was one of the images that struck me between the comparison in the understanding of from astrophysics compared to Kabbalah, is that it's still finding this limit point to which you can't know before, and how far you can go to understand. So here, the dividing line between knowledge and not knowledge is what is the spoken, Vayomer Elohim. Let there be light. This is with the first spoken word. All that emerged through this mystery. Let there be, Yehi, alluding to the father and mother, namely Yud He. So Yehi is Yud He Yud, right? And which the Yud and the He are the first two letters of the divine name, the God's name, right? And the Yud being representative of the father, which is in the minds of the Kabbalists, and as it is in the second creation story, precedes the female, also within the divine. So as God extends out and the universe extends out, in their understanding, male precedes female, and in this first definition, but as soon as you already get into the first utterance, right, the first letters of this utterance, it already is both the introduction of the male and the female. The Yud and the He begins this distinction between male and female. And now you have the possibility of creation afterward. Afterward, turning back to the primordial point to begin expanding into something else, light. Right? So everything back is still the primordial point, what we can't understand. This initial point from which of Reshit, which we don't know anything before it. But here, the first thing to happen after the male and the female, of the father and the mother, of the Yud and the He, is light. And there was light. And here they're twisting it and they're saying light that already was. So it doesn't say, for example, God created light, which is the case for the Rakia, that's the expanse that's coming soon. Here it says that there was light. And so their understanding is that this light actually was already there. It pre-existed this utterance. This light is concealed mystery, an expansion expanding, bursting from the mysterious secret of the hidden supernal aura. First it burst, generating from its mystery a single concealed point, but the infinity burst out of its aura, revealing this point, Yud. So they're imagining now we're moving again from the silence to the spoken to the drawn or written Yud, right? And now we're moving from into the physical space of an actual Yud on into the universe. And this Yud is this point, is this initial point that's breaking through, from which the expansion will happen. Right? Once this Yud expanded, what remained was found to be light from the mystery of concealed aura. Right? So this aura that existed before, when it finally breaks through at this initial point of the Yud, and it's written onto the universe, and you have this one point, now it can expand out. And that first expansion is light from the Yud. So the Yud turns into light. After the primordial point, Yud emerged from it into being and manifested upon it, touching yet not touching, expanding it emerged. This light remaining from aura, namely the light that already was, this endured, emerged, ascended, was treasured away, and a single point remained, so that by a hidden path, it constantly touches that point, touching yet not touching, illumining it through the primordial point that emerged from it. So all is linked to one another, illumining this and that. So they're also, again, imagining in this sense that the expansion goes out from this initial Yud. It never separates entirely, right? And because of that sense that it was always there and expands out from there, everything remains always connected. Touching yet not touching, yet somehow connected. All is linked to one another from this initial expansion from the Yud into light. As it ascends, all ascend merging in it, attaining the realm of the infinite. It is hidden away and all become one. So that in the reverse, if one were to travel back into it, which the Kabbalists see as something that's their goal, right, of this union and knowledge of God, and if you were to go back, one would go back to a place of ultimate oneness and unity. That point of light is light, or it expanded, and 7 letters of the alphabet shone within, not congealing, still fluid. Right? So now they're moving outside of the Yud into 7 letters of the alphabet. The darkness, Choshech, emerged, and 7 other letters of the alphabet emerged within, not congealing, remaining fluid. So here, what's important to understand is that the first 7 are represented not on the side of darkness, which is pulling Choshech from the second verse of Genesis, but the first ones are on the right side, the side of light, right? They're descending in light, and they're imagining kind of here a right and a left. So there's, on the first, it's representing from the right, and the second ones, it needs to be balanced out in the universe, in this creation. So there's 7 other letters that come out on the left side. And now we have a balance of light and darkness, and of the 7 letters balancing out between them in the creation of the world. And again, here we're also getting further defined. Before we had 2 letters, the Yud and the Hey. The Yud was on the right and the Hey was on the left. So they were already being balanced. And now as it continues on, right, now it'll be a total of 7 on the right and 7 on the left. The world continues to get more defined. As you have more letters, it's more defined. It's also from an oral standpoint, the Yud and the Hey are barely at the edge of sound, right? Like in the same way that we wouldn't know how to pronounce, we don't know still kind of how to pronounce the name, the tetragrammaton of Yud Hey Vav Hey. Like Ya is just on the edge of sound, versus as you add these other letters, it becomes more defined. And but still at this point, they remain, here it says, though they're not congealing, it's still fluid. This light and darkness is expanding out and not yet congealing. The darkness emerged and 7 other letters of the alphabet emerged within, not congealing, remaining fluid. In expanse, this rakia emerged, dissipating the discord of 2 sides. Right? So now it's canceling out the 2 sides that are sitting in opposition of each other. Right? And 8 other letters emerge within, making 22, which are the 22 letters of the Hebrew alphabet. English has 26, Hebrew has 22 letters. 7 letters dropped from this side and 7 from that, and all were engraved in that expanse, remaining fluid. Right? So as it's expanding out and still remaining fluid, the 2 sides of right and left are balancing out. Right? And they're now, when the whole alphabet comes together and things are kind of being defined, they start canceling out and finding a place of balance, but they're still yet haven't formed. They're still fluid. And I think fluid here, I wouldn't see it, I should have said earlier, like it's not fluid like water. It's a sense of fluid like changing. Right? It hasn't yet come to form structure. The expanse congealed and the letters congealed, folding into shapes, forming forms. Torah was engraved there to shine forth. Right? So here, if we're imagining this original light that's coming out, that's defined here at the Yud and the Hey, it's just the basic, this elemental principles of difference and balance. And then as they become more defined and extend out into the world from this initial point, and they gain more letters and then have to find with 7 on each side that are balancing each other out, and then finding the balance in the 8 letters and the entire alphabet comes together. And at this point, they start gaining form. Right? So as they extend farther away from their source and start forming, and here now they become the initial forms, maybe rather than in the physics sense of being like of planets and atoms, and I guess probably first, right, it would be atoms and particles and so on, and eventually slowing down to more. Here, as they're extending out and becoming more defined, instead what they're imagining, because remember the Torah and the God and the universe are all the same for them. Here, as they become defined, now Torah was engraved there. The Torah being engraved, being put into a physical space is the image for them of the physical universe being created. Those are one and the same. Right? So if we imagine a map of the universe, when they looking at the Torah in its engraved form here, that is their map of the universe, and again folded in with that, that is the map of God. I think it's 10:30. I think by 30 minutes. I think we're through. I'm trying to. So maybe I'll just recap quickly from the opening. From just these these two Zohar passages, which are actually part of again this long investigation into the opening of Genesis.
I'm going to interrupt just for 1 second because I forgot to explain the structure, to remind everyone of the structure. So Yaron is teaching text for 30 minutes. Sam will also teach for 30 minutes, and then they're going to talk to each other about those texts. And at that point, we can weigh in with our questions. I'm muting myself again.
In the traditional creation narrative, it begins in Genesis at a creation of the physical world that we know well. It doesn't even try to imagine a beginning beyond like what we kind of would see in this world as land coming from the ocean. You know, for example, the creation of land, is just the ocean recedes and there's more land. Like it's much farther along the chain of creation. And what the Zohar text is trying to do, is really go back to the limits of knowledge of creation that we would still understand today, kind of to be the limits of knowledge of creation, and find the answers for that still, because they have to be discovered for them still through the Torah. And what they're finding in this Torah text, presumably here without any knowledge, they have no knowledge of the early universe via physics, right? So what they're discovering, as they write, this discovering treasures in this text, is to say that there's this initial point that somehow holds within it this light that existed already, and when that light expands out and becomes further defined into the universe, it begins to take shape. And as those shapes become more defined, the universe as we know it all was an extension of this original light that came out of this single point. So I think that's enough for to see how these remain in dialogue with physics. I'll shut off my share screen. And hand it over.
And Sam, I'm gonna make you co-host. All right.
Great. Hey, everyone. You can still hear me, right?
Yes.
Yes.
Good. Seeing nodding, thumbs up. All right. So I'm very excited to be back here with everyone. So like Yaron, I'm going to do a quick recap of my earlier sort of introduction to neutrinos. And then we are also, I was thinking about like what text, would be a good text. And I, was reading through what Yaron had sent to me, and I thought, usually we don't actually go in and look at like the actual scientific journal articles when we do, public speaking, public lectures and stuff like that, because it's just so, the language is different. It's like messy. There's all sorts of technical concepts. And I was like, well, if we're going to like read primary sources in the Kabbalah, then we might as well look at a primary source in physics. And so we're going to go through a part of the journal article which caused this recent, round of news about our knowledge of the universe. So these are the same slides, and I'm just going to skip through a bunch. So we talked about particle physics and the origins of the universe through the lens of why is there something rather than nothing, which is obviously a question that not just scientists try to answer, but also theologians, mystics, philosophers, etc. And, my opinion is that I have not seen really a satisfying answer. Different people, have different opinions about how happy they are with the different answers that these different types of thinking and knowing can provide. So we talked about what do we mean by matter. And I think, in a similar way to how Yaron was talking about, like, defining, like, okay, like, nothing doesn't mean nothing. It means there was water. Like, there was already something, and, like, the light was already there. It was just hidden and stuff like that, right? So we all have to kind of define what we mean by stuff, by what we mean by something when we say, why is there something? And so we talked about in the definitions that we were talking about, it means, things made of atoms, not light, energy, heat, which, would not be super satisfying, just as the, authors of the Torah and the authors of the Kabbalah text, just having light is not satisfying. You need land, you need, sounds, you need matter, you need stuff. We talked about antimatter, which is sort of like a bizarro type of matter, where it's like, the opposite of regular matter. And for a long time, we thought that it was equal and opposite, but now we know that it's not quite equal. It's like almost equal, but slightly unequal and opposite. We talked about how when matter and antimatter particles meet, they annihilate into just energy and radiation. And so that was the core, that knowledge about that matter and antimatter annihilate together, sparked the question of, if there was equal matter and antimatter in the early universe, then why didn't it just all annihilate and we just have radiation, right? And so that is sort of a more precise version of this question: why is there something rather than nothing? We also talked about the opposite process. So you can have radiation that comes together to make one particle of matter, one particle of antimatter. We call that pair production, right? So we talked about the history of the universe, how in the beginning everything was really hot and packed close together, a lot of really big and really small numbers. There was inflation, which Yaron referenced, where everything in the universe was thrust apart by an unknown force that we still don't have any, particularly good explanation for where it came from. We talked about the phase where extra matter is created somehow, and that again is the question mark that a lot of scientists are trying to answer. How is it that we started out with equal amounts of matter and antimatter, and we ended up with much more matter than antimatter? We like I said, we already know that matter and antimatter aren't exactly equal and opposite, and so we counted up the ways that we already knew, and it wasn't enough to see the imbalance, to create the imbalance that we see today. So, after this matter is created, it's still all very hot. It's like a plasma, and eventually atoms form as the universe continues to expand from the leftover momentum from inflation, and things cool down, get less frenetic, and atoms form, and then eventually stars and galaxies form. And then we have the modern universe, which has been around for the last 5 billion years or so. So that is again like sort of the history of the universe. According to physics and cosmology. We also talked about the symmetry, right, which is a very important idea. In the same way that Yaron was talking about, having opposites joined into one. The idea of a symmetry is that if you reverse something or you change something, that you can still use the same rules and the same, equations to get precise about things to describe the changed system. And so we talked about mirror symmetry, how, if you throw a ball up and it falls back down, you can also look in the mirror and see the ball in the mirror falling back down. And you can use the same law of gravity to predict how the ball that shows up in the mirror is going to fall as you can the ball in the real world. And the question was, you can use the same law of gravity, can you use the same laws of like particle physics and subatomic, particles? And it turned out that the answer was no. C.S. Wu, who was a Chinese immigrant woman who I talked about, who was sort of cheated out of the Nobel Prize by misogyny and xenophobia for her discovery, discovered that our universe only contains left-handed neutrinos. Remember, the handedness was related to how they spin compared to how they move. So if you take your left hand like a corkscrew, then the curling of your fingers describes the spin, and the direction of your thumb describes the motion. That's left-handed. Right-handed would be the opposite direction, right? So either you're curling the same way, but your thumbs are in the opposite direction, or your thumbs are the same way, but now your fingers are curling opposite direction. Neutrino is, again, a type of subatomic particle, and there's the matter neutrinos and antimatter neutrinos. And we've only ever found matter neutrinos that have this left-handed spin and antimatter neutrinos that have the right-handed spin. That was very exciting, but then people were like, well, hold on, just put up a mirror so that your right-handed antineutrino can become a left-handed neutrino, and then you're fine, right? So if you flip matter and antimatter, you don't end up with the wrong-handedness because you've also flipped the handedness, right? And we call this CP symmetry. So the question was, do left-handed left-handed neutrinos behave exactly the same way as if you put them in a mirror and then switch matter antimatter? Will you still be able to do that same game like I was alluding to with the ball? Will you be able to predict everything about what's going on in the mirror universe using the same laws? And we said we don't know, which is true. We talked about how we asked, do we want this symmetry to exist or do we want it to be broken, which is like a cultural question, right? And it has to do with, our preference for the universe to be elegant and simple and neat, and our also making equations nicer to work with, right, on a practical matter. But on the other hand, wanting to be able to explain where we came from and how the universe was created in a satisfactory way. So we talked very briefly at the end about the actual differences that people are investigating between neutrinos and antineutrinos in terms of this CP symmetry. And so we talked about the idea that there are three different types of neutrinos: the electron, the muon, and the tau. And those three different types of neutrinos can transform from one to the other between when a neutrino is produced and when it's detected. And antineutrinos can do the same. So you have an electron antineutrino, a muon antineutrino, and a tau antineutrino, and they can also transform between each other. And the question was, do they transform at the same rate, or is it more likely to have a matter neutrino undergo this transformation than an antimatter neutrino? And that would kind of be a sign that matter and antimatter aren't. You can't just put it in a mirror and change the antimatterness, right? Because you also would need to mess with the timing if they're changing at different rates. So that would break the symmetry. Okay, and then this was sort of our topics for discussion, right? Matter versus antimatter, symmetry of the laws of physics, beginning of the universe, and like the culture of physics and how we study the early universe. Okay, so that was obviously a whirlwind whirlwind recap. And so the reason that I wanted to focus on those is that when we're going to go through this primary source document, and these ideas are going to be referenced in a really dense way. So this is a journal article. So this is, one of these peer-reviewed publications that you might read about, being reported on. They'll usually say in a new peer-reviewed publication in the journal, whatever, scientists reported X, Y, and Z. Right? And so this is the primary source. So this is what we treat, I don't want to say as truth, but this is what we treat as like authentic evidence in a culture of science. And it's, there was a question at the end of the last session about like, what's been experimentally verified and how can we know that the Kabbalah is a good way of thinking about the universe if it hasn't been, if it's not really something that you measure or that you can detect. And so I just want to, push back a little bit against that dichotomy and saying that in science, we talk about things and there's like this sort of lexicon of like exactitude and precision, but ultimately, whether something is exact or not is a judgment call that's made by people. And that standard for exactitude has changed over the years. And we've tried to get more precise with our definition of exact, which you start to get into a little rabbit hole and you get a little circular. But we, you probably also heard about, scientists being fallible or being wrong. Or there's a lot of studies, in the hard physical sciences, we sometimes like to make fun of like psychology and sociology and ask whether their experiments can be replicated and stuff like that. But it's all a spectrum of inexactitude rather than a spectrum of exactitude. So this paper was written by a group of people called the T2K collaboration. And it was published in the journal Nature, which is a preeminent scientific journal based in the UK. So you'll see some British spellings, I think, at some point, and that's why. When we are taught how to read papers, because just like you're taught how to read the Torah or you're taught how to read Kabbalah texts, you have to be taught how to read a good scientific paper, and you're taught that you're not supposed to read it in order. So you start at the beginning and then you skip to the end and then you scroll through the middle and then you go through and you do a deep read. Is basically the summary. I'm going to not start at the very beginning. I'm going to actually skip to the middle of this paper so you can see the author list. So so this on the right is the author list. So it's rather long. It's over 100 people. And that, when we say author list, again, it doesn't mean that, each person wrote 2 words and then they all strung it together, or that it was one giant Google Doc that everyone was typing into and editing. There's sort of a small handful of people who are responsible for actually doing the writing and the editing of the actual text. The rest of the people are people who contributed to the experiment. They helped build the apparatus. They helped do the calibrations to make sure that the detector was working correctly and that the numbers that they were reading were the right numbers for known inputs. So for things that we already knew what the answer was, making sure you get the right answer. There were people who wrote the software to do the massive number crunching that you need after you have an experiment running for many years. And so this is sort of the list of, it's almost like the credits in a movie rather than like the author of a book. Okay, and we're going to spend all our time, so it's already been 18 minutes or something like that. So we're going to spend all our time on this one paragraph. This paragraph is called the abstract. And again, if you have, most academic texts have some kind of abstract. It's supposed to be like a summary. So it's supposed to tell, someone who is maybe looking for the right article to cite, for example, or to if they want to learn about the experiments that were done to discover a particular phenomenon, this is sort of what you would read to decide if you've got the right article. This is long for an abstract. Most abstracts, I would say, are about half this length, but fine. They decided it was an important article and they wanted a longer abstract. When I was in high school, in my AP physics class, we were taught, for the first time what an abstract was and how to write it. And I very clearly remember my teacher, Mr. Vaughn, who said, if my friends can fit $3 million in 2 years of research into an 8-sentence abstract, then you can too for this lab assignment that I've got for you. Yeah, no matter how extensive or important the experiment is or the result is, the abstract is supposed to be short. So let's go through it. So we start with charge conjugation and parity reversal symmetry. So that is, I never actually said, I don't think, what CP stood for in CP symmetry. So charge conjugation is jargon for the difference between matter and antimatter. We call it charge conjugation because the main difference that people knew about for matter and antimatter was the electric charge. So when you take an electron, which is negatively charged, turn it into an anti-electron, it's positively charged. And that we don't really consider, that's not like a difference in behavior between matter and antimatter, because that's the definition to some degree between matter and antimatter. So we already knew that the electric charge was different. So that's charge conjugation. And parity, parity reversal is P, and parity refers to the difference between left and right. So left-handed versus right-handed parity is just a word. You can look it up in the dictionary. It'll just mean, Merriam-Webster probably says something about directionality or about the configuration, and it just means the difference between left and right is the difference between parity. Is parity. So this symmetry of fundamental particles is a symmetry between matter and antimatter. Okay, so that's kind of like one of the only sort of definitions that they're actually going to give away, right? A violation of this symmetry was first observed in 1964. So a little historical tidbit. And CP violation and weak interaction of quarks was soon established. So this is referring to how I said before, we already knew before this experiment that there were some subtle differences, that CP was not exactly a symmetry. And that violation that we had already measured was in the particles were quarks. Quarks are what make up the protons and neutrons that make up atoms, so they're like 2 levels down. And the weak interaction is a fundamental interaction, kind of like gravity or like electricity. But the weak interaction is only relevant for subatomic particles. Neutrinos, importantly, feel the weak interaction, but they don't feel any of the other interactions. So that's why neutrinos are so promising. They're considered so promising for this CP violation, because they only feel the interaction, which we already know doesn't follow CP symmetry. Okay. Sakharov, who was a Russian physicist, proposed that CP violation is necessary to explain the observed imbalance of matter and antimatter in the universe. So this is what I've been saying the whole time. Why is there matter, and instead of why is there more matter than antimatter, or why is there anything instead of nothing? This is that statement. And Sakharov's proposal wasn't just that you need CP violation, you also need other things, and we can talk about what those other things are later and during the questions if we want. So far, CP violation has not been observed in non-quark elementary particle systems, so we've only seen it in quarks so far. But it's been shown that CP violation in leptons, meaning neutrinos, could generate the matter-antimatter disparity through a process called leptogenesis. And I've kind of been saving this word, leptogenesis. Obviously, the genesis, is a biblical reference, meaning the creation or the beginning. And lepto is Greek for light. So leptons are light particles, and neutrinos are the lightest of the particles that we know that are the matter particles as opposed to like energy particles. So neutrinos are the lightest, so we call this leptogenesis. Then they talk about leptonic mixing. So leptonic mixing is this process that I obliquely and very vaguely described of neutrinos turning from one type of neutrino to another. So that we call it mixing. We also call it oscillation, which you're going to see later. They appear in this particular type of interactions, and it provides a potential source of CP violation through a complex phase delta CP. So complex refers to complex number, so like imaginary, or like an imaginary number. If you remember from your high school math class, learning about imaginary numbers. This variable, delta CP, delta is like a Greek letter, right? This is a number which is a regular or real number that describes how off we are from having CP symmetry. So if delta CP is 0, that means that we still have CP symmetry in neutrinos. And if it's not 0, that means that there is some CP symmetry. And the bigger it is, the more CP symmetry we have. And it doesn't, the way that it works is it's bounded. It's the way that it shows up in the math is that it doesn't, you can't have like a delta value of 1 billion. It only goes from, now you might remember also from your high school math, the number pi, which describes how the distance around a circle compared to its diameter. Delta CP is bounded by negative pi to positive pi. So 0 means nothing, and then it increases, and then actually I'm gonna go a little, we're all adults here, so I'm gonna go a little more complicated. It increases up to half the value of pi, and then as it continues past half the value of pi, it starts to represent less CP violation. So at 0 and at the extremes, it means CP is symmetrical, and in the middle, it means CP is violated a lot, and the further away you are from the middle values, the less CP is violated. Okay. This CP violation can be measured in neutrino to electron, muon neutrino to electron neutrino oscillations and the corresponding antineutrino oscillations. So they're telling which particular types of changes between the neutrinos they're looking at. And again, because we're looking for differences between the neutrinos and the antineutrinos, that's where they talk about that you can measure it in this type of oscillation, the neutrino oscillations, and the corresponding antineutrino oscillations. And they're experimentally accessible, meaning it's actually something that you can actually do as a practical matter using a beam of neutrinos, accelerator-produced beam of neutrinos, so, from a particle accelerator. And they give 2 examples, the Tokai to Kamioka or T2K experiment and the NOVA experiment. T2K is in Japan, and NOVA is in the United States. So until now, the value for delta has not been substantially constrained by neutrino oscillation experiments. But here we're going to report a measurement. So that's very exciting because it's not yet been constrained. We're going to report a measurement using long baseline neutrino and antineutrino oscillations observed by the T2K experiment. This is a really long sentence, so we're going to break it down half and half. So long baseline just means that the neutrinos were traveling for a long time. So a long baseline usually kind of means more than a couple miles. So these experiments were about 100 or more miles of the neutrinos traveling. And it shows a large increase in the neutrino oscillation probability. So it means that neutrinos were more likely to change from muon type to electron type than antineutrinos. Large increase in neutrino oscillation probability. And here's again where we get into like this definition of precision and exactitude that we use in particle physics. So the question is, of those values for delta CP between negative pi, positive pi, which ones are still possible and which ones are no longer possible? And so we talk about excluding values, right? So which values are no longer possible given the results that we've measured. And they exclude the values that result in an increase in the antineutrino oscillation probability, because we did observe an increase in the neutrino oscillation probability, so we can exclude the values that would say there's an increase in the antineutrino probability. And they exclude them at 3 standard deviations. So we'll get into in the Q&A if we want. If we talk more about like what these measures of precision and exactitude, how we count standard deviations and what that means in terms of our certainty. And the confidence interval, meaning the allowed values, right? So we talked about the excluded values kind of qualitatively. The allowed values, and here's where they talk about here's where they define delta CP in terms of pi, right? So they say the allowed values are between -3.4 and -0.03. So these are the allowed values. So they're basically saying delta CP is probably not positive. It's probably negative. And they give 2 different ranges because there's other parts of the theory that describes neutrinos that we don't know. And so there's two different possibilities for this other part of the theory, and it results in a different value or different range for delta CP based on this other part of the theory that they're not going into. And they say our results indicate CP violation in leptons. So this is the classic understatedness of science and scientists. They're claiming that they discovered, that neutrinos don't follow CP symmetry. Our method enables sensitive searches. So they're saying that also they did a good job developing the analysis that they could use again to do a better job in the future, right? And then they say we still need to compare whether the imbalance created is bigger than the existing one that we already knew about. So, so that's the abstract. So we did it, we made it. It was kind of a slog, and that's, I think whenever you're reading something that's difficult, in my college philosophy class, we had to read Kant, and I found Kant to be much more of a slog, much more difficult to parse and to understand, and every sentence had many different clauses, et cetera, than an abstract like this. But maybe that's because I've been reading so many abstracts, and I already kind of am familiar with the concepts. But they're summarizing, they started building their detector in the 90s. So they're summarizing decades and decades of research and hundreds of millions of dollars of funding in, these sort of 8 or so sentences in this paragraph. And the paper is many pages long, and it's got equations and plots and charts and pictures and descriptions. So we're not going to go through that, but this is how we, communicate our results, and this is how we try to build on each other in deciding what we want to believe is how the universe behaves. I would love to turn it back over to Rabbi Shira, and we can maybe start our discussion and our questions and answers.
So what of interest am I going to say right now? And Alan had a question, which you can see in the chat, and about 3.14 and 3.41, which you can look at.
Yeah. Do we want to just clear that up real fast?
Sure.
Yeah. So I mentioned that those are the bounds, and actually it's thinking about it like a number line is actually a misleading picture. You should actually think about it like a circle that goes around. And so the the ends, can I get, the ends, the two extremes actually represent the same physical situation. So you can actually think about it more like a circle. So you start at negative pi, and then you increase, zeros at the top, and now you're in the positive values. Once you get to positive pi, you're back at the beginning. And if you want, the numbers keep going. So if you keep going, you start going around the circle again. And so you can talk about values greater than 3.141 or whatever, but it's equivalent to a value that's within that range. So what they did is they were trying to just give a range that straddled the crossover between minus pi and pi. Yeah.
So I do know that on the call we have mathematicians and physicists and scholars of different kinds, and I was I'm none of the above, and I was struck by the reminder of numbers, real and imaginary, and I'm not sure that I see the difference now between real and imaginary, and so I just want to put that out, and certainly to invite those who have questions, to invite Yaron and Sam to talk with one another. This was initially conceived as a conversation between them, and I was going to listen in. So now we can all be part of that conversation together. And do we have questions? Alan, did you have a hand up? Go ahead.
For a number of years, I gave tours at the Botanical Garden, and I would take a group through the greenhouse and talk about the different requirements for plants in the different biomes, a tropic area, a desert area. Another time, I'd give a tour through the same place, looking at the same plants, but it would be a group interested in the use of plants for medicinal reasons. Another time, the use of plants for landscaping. And with the same plants, I would have a different story to tell. And it struck me listening to both Sam and Yaron today that the Kabbalists and the physicists are looking at the same world through different lenses, and that both of them are seeing truths that aren't mutually exclusive. Now, this may be obvious to many people here, but it struck me, this is what I took away today from the now 3 sessions that we've had, that my challenge, if you will, to Yaron last week about the testability of the Kabbalistic system is not relevant. It's a matter of how you're looking at the world and the construct you build to understand it.
I had a question for students. I think the presence of pi, the little that I understand about the presence of pi, and I'm trying to understand why CP violation would be bounded by a measurement of a circle. Like, what do the two have anything to do with each other?
Yeah, that's a really good question. So there's sort of some sense, the sort of famous physicist Richard Feynman has a little section in, I think, his autobiography about this, that pi was sort of defined by a circle, and therefore, whenever you see pi in an equation, there's got to be a circle somewhere. And when he raises this during his, description of his college years, and he would say that whenever he saw pi, he would try to figure out where is the circle, where is the circle, here it's really obscure. So I can try to describe to you, but it's not going to give, I don't think, deep, revelation about the circle. Basically, the idea is that the way that we describe in physics processes that repeat is we think about them like a pendulum or something like that goes back and forth. We call it periodic because there's a period that repeats. And the way that we describe it mathematically is we think about it, we model it also as if whatever the process is describing a clock going around a circle, which also repeats, right? And so we can talk about how far along this metaphorical circle have we traveled in our process, so from 0 to 2 pi. And once you get back to 2 pi, then the process repeats again. So the actual physics, the actual physical object doesn't have to be moving in a circle for us to model it mathematically this way. So we talk about this in electricity when we have current, like alternating current that repeats. We talk about it in like the seasons, like when we model the seasons, we know that the temperatures increase and then they decrease, and they increase and then they decrease. And we use pi also, we model it as if you're going around a circle. And so when we ask how far along are we can say either we're 6 months in, or we can say we don't use this language, we can say you're halfway around the circle. And so that's, the connection to neutrinos is that, we see this word neutrino oscillation. I realize now you can't see my screen actually, but I mentioned neutrino oscillation, and that's because these transformations from one type of neutrino to another happen periodically. So it's not just a one-directional thing, as it goes from one type to another and then back, or like kind of like a rotation between three. And so that's where the circle comes in. It's a little bit obscure and abstract. I wish it were more exciting.
And Paul, on one of our several mathematicians aboard, Paul Davis, and then Yaron, is there something in circles that an association with circles with the Kabbalah system that you might respond to? But Paul, go ahead. I need you to unmute, Paul.
This is directed to Sam. There is a tension between quantum physics and general relativity. Very briefly, you're thinking of the universe, things that are very large. One generally thinks of general relativity. If one is thinking of things very, very small, you're thinking of quantum mechanics. I'm wondering, you're talking about the universe in the context of these very tiny, teeny things. Do you find this tension arising? That's
a really good question. I'll answer shortly. No, because the tension arises sort of in the very early universe. That's where the biggest tension is. If you're like talking about before inflation, then you have to deal with quantum gravity. But everything after inflation, the idea of quantum gravity is not as necessary or important until, unless you want to talk about black holes, which is like a late universe or modern universe phenomenon. I would love to talk a little bit about the something that I encounter when I have been talking to my friends about this project, and also in 2012 when I gave the talk on the Higgs boson in relation to Kabbalah, and the idea that people always bring up is, oh, so like did they know about the Higgs boson, or like did they think, did they know this idea of CP violation, or did they predict that, one image that I want to draw as an analogy is this idea of the different letters of the alphabet materializing and then solidifying is very similar to me to the idea of like atoms, like which used to just be, their constituents were like diffused throughout the universe as a plasma, and then they kind of congeal, to use a suggestive word from Yaron's text, into atoms and into stars and whatnot. And and there's this question of, did they know that, you know, the universe was a hot plasma and then it cooled down and it expanded and cooled and whatnot? And I feel like that's like the wrong question, you know, because it's not, again, it's not about validating like what Alan was saying, right? Like, it's not about like trying to figure out were the Kabbalists right about the early universe and that's why we build our big telescopes, right? I don't know if you have like a different opinion on that, Yaron.
Yeah, I agree that to me, like trying to play out notions that they had somehow understood the early universe without any way to measure or investigate, or telescopes or giant underground, you know, highly sensitive measuring devices and so on. It's that's not about right. It's not about claiming that the Kabbalists were somehow proto-scientists. And then the other part is just like to realize in some ways, like, are they fundamental? Some of me wonders, I guess, what I would throw out there is, if we didn't have these fundamental stories of how we think the universe had to exist, even before we had the ways to measure it, if we had a different way of seeing it, would we end up finding different results in our measurements? Like, it turns out that, I guess what I say, it turns out that the things that Sam is looking for in neutrinos are the same things that the Kabbalists were looking for in their understanding of the beginning of the universe. And one wonders to me from like the question of observation and what are, I know like from the little, again, understanding that I have from my reading into cosmologies, that the question of observation on how it impacts the physical world, and who knows what our sense of what the results should be have impacted it. So I guess to give like a particular example of it would be that, and this that didn't come out in the Zohar text, but the Zohar also understands that if the right and the left balance out, there's nothing left. And so that if you have matter and antimatter balancing out, there's nothing left. So they have to explain that it can't be a perfect balance. I don't know if you remember that Rabbi Yishmael text when he goes up to the court of God and he asks, like, please just put it toward the side of mercy. Just remember to stay toward your side of mercy and your attributes. And if you list the divine attributes that are listed in Exodus, when Moses is up at Sinai, are leaning toward the side of mercy, not, right, there's Rachum, V'chanu, Erechbam, and so on. All those lead to the side of mercy. And then at the end, you also have the iniquity that gets passed on to the generation. So the Kabbalists understand that balance, or that imbalance, I should say, of attributes is the reason why it leans toward mercy, which is the right side, in matter and creation, rather than destruction on the left side. So that even in this like early trying to understand the attributes of God and the right and left of the creation, according to the Kabbalist understanding, it has to be somewhat imbalanced for there to be anything rather than nothing. So, and the same, like when I was asking about the circles, that of all the images, other than the initial point, the first shape that arises in the Zohar passage is this ring that expands out. So why in the earliest universe would neutrino CP violation be measured by the measurement of a circle? Right? How fundamental is this ring that shows up in the beginning? Right? So like, why is a circle more elemental and defining of rules of the universe than anything else? Again, it's not that, so I guess I want to throw out there is that not that these are early scientific understandings, but like, is it possible that because of the way we thought the world has to be, we're measuring the world to meet those standards rather than the other way? Yeah.
Yeah, absolutely. I mean, so I see more questions. I want to just respond really quickly. We, in you know, talking about like the culture of physics and the culture of science, there's, especially in physics, there's this idea that we're like objective and we're like pursuing the truth, right? And a lot of, not a lot, I guess some people, I count myself as one of them, you know, have started sort of advocating that like the types of people who are doing the science impacts the questions that we ask and the questions that get funded and the questions that get answered, right? And so we can, you know, this is most recently in the context of like diversity and like, you know, who's you know, if we have just a bunch of automaton white straight men, you know, doing science, we're only going to get the ideas that they have heard in their upbringings and their educations and whatnot. And if we bring in a diversity of people, immigrants, people of color, you know, women, right, which is somehow still considered diversity in the physical sciences, you know, different people have different life experiences. And to Yaron's 100%, I agree with his point. You're gonna look for different answers, and you're gonna ask different questions depending on whether you were raised with the myths of the Kabbalah or the myths of the Tao, you know. And I 100% agree that our conception of the early universe is impacted by the, you know, the creation myths of the universe. Not that the early universe itself was, but that our understanding of it is. I also, you know, that's like a rather abstract statement that, oh, we ask different questions, we answer different questions, we have different priorities or whatever. But we in science, in particle physics, there are instances where it's very clear, it's been measured actually, the different answers that we get because of these preconceived notions. One example is early in the 1900s and in the late 1800s, people were trying to figure out what the electric charge was of the electron, which is a subatomic particle that carries electricity. And the original experiment was done by a scientist named Milliken. You might have heard of the Milliken oil drop experiment. He measured the charge on the electron. And it was a very early apparatus. It was not super precise or whatever. And it turned out that his measurement was high compared to the value that we know today. And you can look at a graph showing the accepted value of the charge of the electron as a function of time, as a function of year. And it slowly decreases. But it's not a straight line. And actually, there was a slow slope for a little while, and there was a jump. And what had happened was people trusted Milliken so much that as they were biased towards his value. And as the techniques got better and better, and people were getting lower values, they were coming up with as many excuses as they could to assume that they had underestimated instead of that Milliken had overestimated. And finally, it became, you know, incontrovertible that there was a big jump that they needed to do. So 100% agree that, like, you know, the questions we ask and the questions that we get answers to are impacted by our previous knowledge and our previous experience and our previous, you know, philosophy. Yeah.
We're going to squeeze in another question. Steve, do you still have a question? If you do, if you could unmute yourself.
I was just going to add to that discussion, because it seems to me that we also know even that the human brain has ways, things that appeal to it. And so one looks for, or I would anticipate that one looks for theories that coincide with what the brain wants. So the whole idea of symmetry being something that we look for, and at the same time, there being limits to our interest in symmetry. They've done experiments with images of faces where you put a mirror and taking it, so you're really only looking at one side of the face reflected, and it gives you the impression of an entire face, but it's really symmetrical, and people find a problem with that. So, you know, there's all these things that have to do with what appeals to the explainer, if you will.
I'll jump on it. When I was discussing this with my brother, who's in art history, he noted this question that we presume that we like symmetry because, like, if we're building blocks or something like that, we often will like build things that are symmetrical. But in fact, we find perfect symmetry disturbing. So what is it about that? Right? Why do we find perfect symmetry disturbing? And if that's, and why would we apply the same rule to a phase as to the universe? And I think, like, again, folding into that, like, I presume that most cosmologists don't know about the Kabbalistic myths of the creation of the universe. So why still would these like, why do they become part of the somehow, like, the narrative in which we see the world, despite the not being able to actually piece together a chronology for that knowledge? And, you know, again, to bounce off of Steve's point, like, if in fact if we found symmetry to be just fine, you know, would we be okay with that in the universe? You know, like, is that possible that the universe would exist if we found symmetry fine? You know, where do these understandings come from? Like, where do these places of comfort in our knowledge of our world and the universe, where do you source them, and how do they impact how we interact, both on the normal scale of human interactions and our interactions with neutrinos? You know, why would those rules be consistent?
Yeah, I also wanted to touch on your the concept that you brought up of the general, particular, general, which I think, you know, is related to, like, why should we suppose that just because we like symmetry in our macroscopic world that we should be looking for symmetry in subatomic particle physics? And I think the idea of general, particular, general, that, you know, if you see this general concept applied to one particularity, that you can assume in the legal context or in this particular context that there's probably applies also to other things. That's like a way to define symmetry, right? The idea that you see something in one situation, and then you can also assume, it's a grand assumption, that it also works in some situation that you have never seen before, right? You know, the idea, and we know that it works a lot. You see an eye on, you know, someone's peeking their head out from around the corner. You see they have one eye, they probably have another eye, because in the past you've seen that when someone has one eye, they also have another eye, right? But you know that if they have a birthmark on their cheek, that they probably don't have a birthmark on their other cheek, you know? And so it's like you know, it's very deeply intertwined, in my opinion, with the idea of symmetry. So can I try to summarize my understanding of the application of general, particular, general that you talked about? It was basically the idea that, you know, this idea, God said, let there be light, and there was light. Like that phrasing of God said, let there be whatever, only kind of appears once. And the idea is that actually the creation of the rest of the universe also had this God said. And I know that the voice and the saying was like an important part. Am I understanding that correctly? That it's basically saying the other stuff didn't just magically appear, that it was God said that caused the rest of it also to happen.
I think in this case it's bound. So I can pull it up quickly.
It's a little different. It's not.
Yeah, it's a little
I'm not quite there.
Part of it is that the opening. So Breshit bara Elohim et hashamayim et haaretz. In the beginning, God created the heaven and the earth. And maybe Ema, you could pull up the verse by verse. But at the end of the creation story, there's another summarizing comment that's almost identical, and it is, I could probably find it, but the.
Do you want me to pass off the screen sharing to you?
It's okay. I can just cite it, or when I get it. It's But in any, while I look for it, I'll try to explain the principles. The idea is that at the beginning and at the end, there's general. This is the creation of the heaven and earth, and this was the story of the creation of heaven and earth. And then everything, that's the general knowledge, and everything else is the detail. But you can't derive general principles from details unless there's a detail in the middle of it, is the idea of klal u'prat. So you have to have had I guess an example of it in a legal context would be that if you have, you know, you can never, this is not a real one. You cannot eat milk and meat together, and that would be the end of it. You can't actually derive particular examples of it. But if they then go to define the particulars of it, and then generalize in the end, you can expand upon that same principle. So it has to have both general and particular examples.
Particular, yeah.
And the line here is at the chapter 2, verse 4 of Genesis is Elo Toldot HaShamayim Va'aretz, such as the story of heaven and earth when they were created. Bivram. So that's the end. That's the end general principle, or the end. Sorry, yeah, general. The opening verse is 1:1, and the second one is chapter 2, verse 4.
Gotcha.
And so I'm going to bring the session to a close, and for everyone who has questions that would help propel the last session, I hope you will send them to me so I can forward them to Yaron and to Sam as we think about mapping the universe. And from what I understand, a little bit about, very little, about Kabbalah, that the universe in a sense is the map of the body of God. What would it be to see the world that way? How do we map the universe? And I'm thinking right now, at this moment, about the phrases I hear a lot about racism and also about the coronavirus, that we are only beginning to know what we don't know. And thinking about the limits of knowledge, the drive to know of how much we don't know. But also how important it is to understand how all of this is part of the fabric of our universe. So, and bringing it back to this moment and hearing the phrases from news reports, from commentators, from our study today on the nature of knowledge, of questions, and what we need to know, or the questions we need to ask. And I would like to, we started with a blessing. I want to end with a blessing. It's one of my favorites. There's a whole category of blessings that fall into the section called wonder. So blessings of wonder. And this is not the command to study, La'asok b'divrei Torah. This is a blessing of wonder about wisdom. And it ends with, and I'll say it and then we can say it together, Shenatan mechochmato levasar vadam. This amazement that God has shared divine wisdom with mortal creatures. And I think that's what we're partaking in today. So, and we can do it once while everyone's on mute, and then I'll ask you to unmute yourselves too, so we'll practice. So the first part, we can say it together, muted. Baruch atah Adonai Eloheinu melech haolam. Now, Shenatan mechochmato levasar vadam. Flesh and blood, basar vadam. Blessed are you who has shared your wisdom, divine wisdom, with human beings. So if I can invite you to unmute yourselves. Thanks. And let's say it together. Baruch
atah Adonai Eloheinu melech haolam
Shenatan
chochmato
levasar
vadam.
Have a wonderful day, everyone. A day filled with
You too.
wonder. Sam and Yaron,
Thank you, Sam. Thank you, Yaron.
Come on your own.
Pleasure.
Thank you, Yaron.
Thank you all.
Thank you.